Okay, let's go ahead and go over the practice quiz here. Graph the following circle. We should know the three words of opposite, opposite, and square root when they give us an equation of a circle in standard form. Remember, that's called standard form. So therefore, my center is 2, -3. I plot 2, -3, and I go out 6 in each direction. So that's 6 right there. This is 6, and this is 6. And then I just do my best to draw a circle from there. Okay. Number 2, complete the square and find the center and the radius. So remember, in completing the square, we arrange our x's together, and then we put a plus blank. We arrange our y's together. Okay, that's a y plus blank. And my constant goes to the right side, that's the 4, and then plus blank, because whatever I add to the left side, I must add to the right side. So to complete the square, remember we take half of b, there is b, so half of 4 is 2, and then 2 squared. Remember, it's always half of b squared each time to complete the square. So half of 4 is 2, 2 squared is 4, that's why we have plus 4 right there. Then we take half of -2 for this b is -1. -1 squared is +1. Remember, when you square any number, it's always going to be a positive. You better not have a negative in any of these. So I really added 4 plus 1 to the left side is 5, so I must add 5 to the right side. So I see the plus 5 there, and 4 plus 5 is 9. And I factor this perfect square trinomial into x plus 2 quantity squared, and this perfect square trinomial into y minus 1 quantity squared. That's Algebra 1 review. I've already told you the shortcut. Just take half of the b and plug it in right there. Half of the b, plug it in right there. Okay, so that's all Algebra 1 review. Now it's looking like number 1. I do opposite, opposite, square root. So I get -2, +1 for my center, and the radius of square root of 9 is 3. There's my answers. All right, number 3. Right, equation of the circle is center this, so I know my center is right here, so that's the whole left side of the equation. I can fill in right now, nice and easy. I'm always doing the opposite and the opposite, so x plus 3 quantity squared plus y minus 2 quantity squared, and now I have to find out what the radius squared is. Remember, this equals the radius squared. Well, very simple. If I don't want to have to plot that and use Pythagorean theorem, I can sit there and write out distance formula and do that. And really, when you're doing distance formula, you just ask yourself, how far is it from -3 to -5? That's a distance of 2. How far is it from 9 to 2? That distance is 7. That's why you see me write those there. And then I square each one and add them together. So 4 plus 49 is 53. And that's where it is right there. Okay. You know, like I said, you could plot those 2 points, draw a right triangle, do Pythagorean theorem, or write out distance formula itself and do it. But that's a simple way of doing the distance formula right there. All right, number 4. Since we know in inscribed quadrilateral, the opposite angles are supplementary, meaning they add to 180. Since that's 90, angle 1 has to be 90. They give me angle 2 of 114, so 114 from 180 gives me 66 for its opposite angle. Very simple. Okay, number 5. We know this is 90 degrees because it goes to the ends of a diameter, which means the whole arc here is 180 degrees, and the inscribed angle therefore is half of that, which is 90 degrees. Anytime it goes to the ends of the diameter, which you will see on the decast, you know to put a 90-degree angle on there. And then I told you that these two were congruent, which now means I have an isosceles right triangle. Okay, so that means both these are 45 degrees. Everybody should know that for an isosceles right triangle. So that means I set angle F equal to 45 as I did right here, and just solve it. Subtract the 4 across, you get 41, and then divide by 4, 41/4. Okay, you can't see that fraction there. All right, let's come over here to number 8. All right, number 8. We have 2 secants here. I want to, if I'm dealing with the angles, an angle out here, and therefore the intercepted arcs, it's always the big arc minus the little arc, or I can say outside arc minus inside arc, meaning closest to the inside, meaning closest to, and the one outside, the furthest away from angle P here. So it'll be arc BD, and the closest or the inner one would be AC. So outside minus inside equals double the angle. is one way of saying it, or I could say outside minus inside divided by 2 equals the angle. I like to end up saying outside minus inside equals double the angle because that's going to be the first step I'd have to do anyway. If I did outside minus inside divided by 2, I'd have to multiply both sides by 2 as my first step. So I'm just eliminating that step and just writing it outside minus inside equals double the angle. So that's what we have right there. We don't know what AC is. We're going to solve for it. So it's called X. 2 times 14 is 28. That's negative X. So move it over to the other side to make it positive X. Subtract this across. 156 minus 28 is 128. Number 9, now we're talking about lengths with tangent. Whenever we have a tangent, it's squared, so that's tangent. Don't forget, if there was a center of the circle, that would be at 90 degrees to the center of the circle. That's not involved in this equation, in this problem, but just remember that. You should always be reviewing stuff you know about tangents and or secants. Whenever I have a secant, I know it's the outside segment times the whole segment, meaning to the other point. So in this case, it would be PB times PC. So the common error students make, they do PB times BC, the outside times the inside. It's never the outside times the inside, it's outside times the whole length, which includes the outside, like I have drawn here. Make sure you have that down. So it says find PA. So PA, we don't know what it is, so it's called X. PB, they give me is 16, and BC, they give me is 33. Well, I have to remember, when I have a tangent, I square the tangent, so that's why it's X squared here, equals the outside, 16 times the whole length, 49. 16 plus 33 is 49. How do I solve that equation? I have to take the square root of both sides. So I can take the square root of each number individually. Instead of multiplying that whole thing to get on a calculator, still give me the same answer, but I want to use my brain instead. Okay, so square root of 16 is 4, square root of 49 is 7, and 4 times 7 is 28. So X equals 28. Number 10, similar one. Again, we have outside arc minus the inside arc equals double the angle, just like number 9. So the outside arc, 170 minus the inside arc, 16 minus 16x minus 9. Don't forget to put parentheses around it because you have to distribute that negative through there. Equals double, that's why there's a 2 there, the angle, which they tell me is 5x plus 3. So now I distribute the negative through there. And the negative times the negative is a positive, so it's 170 plus 9 gives me 179 minus that 16x, and then double the 5x plus 3 gives me 10x plus 6. Now I get my x's to one side. I always take the smaller amount to the bigger side every time, so I end up with a positive. So I'm adding that 16x across, gives me the 26x, and then I'm subtracting the 6 across, gives me 173. Then I divide by 26. It does not divide in evenly, gives me some decimals, so I can just leave it as the fraction 173 divided by 26. It does not simplify. 2 does not go into it. 13 does not go into it. Okay. All right. That was 10. So let's get rid of that now. Come back over here to 6. Again, measure of angle G, we know is 90 because it goes to the ends of the diameter. Same with J, goes to the ends of the diameter. So both of those are 90 degrees. If arc JH is 60 as I have it here, then obviously I know my inscribed angle is half of that, 30. If that's 30, then angle 1 plus angle 2, we know are complementary angles, which means they added 90 degrees since I already have a 90 here. So 30 plus what is 90? 60 degrees. Okay, which would then make sense because then this intercepted arc would be 120, and the 60 plus the 120 equals the total of 180. The hemisphere, I mean. All right, now it says measure of angle GFH. GFH is right here. Plus this angle, GHF. Well, since this is 90, angle G is 90, then these two have to also add in 90. Okay, complementary angles, review that vocabulary word. 2 angles that add to 90 is complementary versus 2 angles that add to 180 is supplementary. Always be reviewing your vocab as you're going through this, even if you don't need it. You review your vocab so you're ready to go when it comes to DCAS. All right, and finally, measure of arc FJH. FJH obviously is the whole thing right there, half a circle, 180 degrees, very simple. All right, number 11 now. Again, we have a tangent Remember, we always square tangents, so that's why it's x squared. And then for all secants, it's the outside times the whole. So notice they gave me the outside, PB is 4, and they gave me PC, the whole length of being x plus 17. So they gave me the outside and the whole, both right there. So I just multiply those two together. Then I distribute a property, and it's a quadratic, so I set it equal to 0. So I subtract these across, and I get this. This does not factor, so therefore I have to use the quadratic formula. The quadratic formula, for those of you who still don't have it memorized, is negative b plus or minus the square root of b squared minus 4ac all over 2a. I just added this to your DCAS sheet. So when you got that today, that is on there. Now, the reason I didn't have it on there before, just so you know, is because on the DCAS itself, it's going to give you that formula, so you don't have to have it memorized for the DCAS, but you should memorize it because you'll use it a lot in Algebra 2 next year, and you should have that memorized there. So anyway, I added it to the DCAS sheet, even though you technically don't have to have it memorized. That's the reason it wasn't on there, is because on the DCAS sheet, I want to have everything that you need to actually memorize. That was not going to be given to you. That's why, for example, there are not volume formulas on there when we get to volumes of three-dimensional objects, because those volume formulas are given to you on the DCAS sheet, just so you know. And of course, I'm trying to limit it down to 2 pages of scrunching everything in 2 pages. So I have to choose what I, to put on there. And so I was just choosing to put on stuff you do have to have memorized. Not that you can get off the DCAS, you can get off their formula sheet on the DCAS test itself. All right, so remember this b squared negative b and all this, that comes from the standard form of a quadratic, ax squared plus bx plus c. So I forgot ax squared, I said it and didn't write it. So a is the coefficient of the quadratic term, or the x squared. B is called the coefficient of the linear term, which is the x, and c is your constant. And so those are the values from this equation right here in the black, this piece on the left side that I'm filling into the quadratic formula. That's what you see me filling right there. And then I put in my calculator, because it does say round to the nearest tenth in the directions. So I now just type that in the calculator, and I get 10.5. Notice it says 4 plus or minus. Well, if I would have put in a minus in there, I would have got a negative answer. That's why I didn't have to do the minus. Okay, if they both count to positive answers, I have to have both of them down there. But 4 minus the square root of 288 is a negative answer. So I just had to do the 4 plus. Real life stuff, you can't have negatives. Okay, number 7 now. These are all tangents. You should remember, from a tangent, when a point outside the circle is tangent to the circle in 2 different spots, those tangents have to be congruent. You've done this in one of your problems, or several of your problems before. So all those pieces have to be congruent like this. So AB, it tells me the whole thing is 26. When they tell me AE is 10, well, then that makes this 16, because 26 minus 10 is 16. That makes this 10 over here, and that makes this 16 over here. Then it tells me CF is 16. So CF right here is 16, which means this over here has to be 16. And it says find the length of AC, or the distance from A to C. Remember, nothing above it means the distance from A to C. So from A to C is down here at the bottom, and 10 plus 16 is 26. And lastly, number 12. Okay, AP is a tangent. So again, when it's a tangent to the center circle, we always know it's 90 degrees. I have that memorized, gone over that many times. We see we have X there and X there, and then it tells me AP is 24 and BP is 18. I have a right triangle, so I can use Pythagorean theorem. And then obviously X plus 18 would be my hypotenuse. So that's my C right there. A squared plus B squared equals C squared. Okay. And so you square out x plus 18 squared, and you get x squared plus 36x plus 324. Again, this is Algebra 1 review. And then the x squareds end up canceling out right there. I go ahead and subtract the 324 across. I get 252. Divide by 36 on both sides is my last step, and you get 7. Okay, that's all Algebra 1 pre-algebra steps. Now, Those of you who have your Pythagorean triples memorized, you would have been able to go to it right away because you would have known 7, 24, 25 was a Pythagorean triple. So once I see a 24 right there, I'm thinking, okay, I got to see if I have a 7 involved in one of the sides. So let me probably put a 7 in there and a 7 in there, and then the other one has to be 25. 7 plus 18 is 25, and I could have got it just like that. So if you're smart enough that you memorize your Pythagorean triples, you can write down 7, 24, 25 Pythagorean PT for Pythagorean triple, and therefore your x is 7. Otherwise, you have to work it out like I just did right there. So I've shown you both ways. All right, that ends this review.